welcome back to the Green Connection. We have a really exciting show today. We've talked about having robotics on the show for a long time. Never found anybody that we could work with to do this until the Folklife Festival, and I saw the Scottish bagpipers marching. Leading the parade was a robotic machine. And so I ran over and got the students, and the students got me with their instructor, who is the head of the science department at Brooks Academy, Jeremy Rios, who is my guest today. And we've got students who are going to demonstrate the robotics, and it's kind of scary because we're all going to be replaced one day with these little mechanic robots, okay? Jeremy, welcome to the Green Connection.
Welcome.
There's nothing greener than robots. They don't eat. They're totally sustainable in their livelihood. Robotics, it's been popular in the States. How many years?
It's always been popular, I guess. It's now just becoming more mainstream and accepted.
And they're adapting it to the needs.
Mm-hmm.
However, I was reading on the history of robotics, and in the early history, in the 400 ADs, the Egyptians used a form of robotics to build the pyramids. How did they do that?
They use like hydraulics, so they use what they had available to them, and so we actually use a method of that. It's not quite hydraulics, but it's called pneumatics, but works off the same principle.
The mindset, though, was they had a very strong mindset as to what to do and how to do it.
Mm-hmm.
And I noticed there are 3 laws that robots, I don't know if this applies to everything, but one is the 3 laws. They're kind of nice and kind, unlike the world today. A robot may not injure a human being, or through inaction allowing a human being to come to harm. That's nice.
Yeah. So those are the sci-fi, the 3 laws of a robot in sci-fi, or.
And a robot must obey the orders given it by human beings, except when such orders would conflict with the first law.
Mm-hmm.
So that's nice. We ought to have that, introduce that to the public today. And the third is a robot must protect its own existence as long as such protection does not conflict with the first or second laws. So this sort of protects you for the future, so the robots don't take over the world and get rid of the rest of us. How did you get into robotics?
It's a matter of just designing and building things.
So what did you do before you came to Brooks?
Well, I worked at Southwest Research, and I was going and getting my chemistry degree.
And so how long have you been working with the students at Brooks?
We're going on about 4 years now. So.
And have they been in some competitions?
Yeah, we actually compete in a division called FIRST, or it's a competition that's run by FIRST, which stands for Inspiration of Robotics and Science and Technology. So it's a nationwide, not really nationwide, but global-wide competition. So teams from all over the world compete, and they design and build robots, just like what we have, one here and one here.
And where did they place?
Yeah. Where did we place? And so we competed in multiple competitions. In one of our competitions, we actually made it to the final rounds, and then fortunately we got knocked out, but we got far. So.
Well, that's great.
Mm-hmm.
How do students get enrolled in the robotics side of the science department? Is that a special segment of the class, or is that just normal part of the total science program?
So at Brooks, we have the robotics team itself is an after-school club that anyone can join. But because of where we're competing, we're part of FRC, which stands for First Robotics Competition. There's various other levels that they can compete in as well, but our main students are anywhere from 9th to 12th grade. So as long as they are in 9th to 12th grade, then they can join the team.
What do they have to know or be strong in order to be the deal with the robots, because that is different than science in general.
We accept and actually encourage students from all backgrounds or all interest levels to join, because it's not just about building or designing and programming. It's about, there's a whole wide range and a whole wide gambit that encompasses robotics. So for example, we have the marketing side of it. We have the website side, like designing a website. We have people to go out and spread robotics to the community. So it's more than just science and math. And
Well, we have some demonstrations. We have some students with us, which you'll meet a little later. And so what are we going to see now?
so we'll see a small rudimentary version of what we had to compete with.
And the students designed and built these themselves?
Yes, so the ones that are on this side and that side are actually built and designed by students from different schools.
And you're going to explain what's happening as they're demonstrating?
Yeah, we'll have the students explain, yes.
Okay, let's demonstrate.
Okay.
So I'm Andrew White with the Brooks Academy Robotics team number 5754. I'm here along with some of my members, or some of my team members. Jason, he's our co-captain of the team. We have Sarah Cervera, she's our head of outreach. We have Matthew and Caleb, they're some of our drivers for the robot. And we're just gonna be here talking about the robot and explaining it a little more in detail. So I'm gonna pass it over to Jason.
All right, so our robot, it gets its power through this battery right here, and this battery is connected to a switch. So the switch is able to turn the robot on and off, and the switch is connected to what's called a power distribution panel, and that panel sends the power throughout the whole robot to the motor controls and the motors, and those motor controls send like commands to the motors and tells them what to do, and that allows the elevator to move up and down, or allows this right here to move in and out. And we also have this router right here. This router connects to this computer, and that's how it sends commands, and that's how those controllers connect to the robot, and you could drive. It allows the robot to be driven through those controllers. And now Sarah.
Okay. So when we're brainstorming and we're making our sketches and things like that, we decided to use pneumatics. And when we used pneumatics, we used this pneumatic cylinder. And in order for this to work, we have our air compressor here, which transfers air into our tanks, and then our regulator, which shows how much air goes in and out in order to make this part come out. And this is the hatch panel. So the purpose of this was, during competition, we have to grab these hatch panels so it comes out in order for us to hook it and get it on. And in order for this to move up and down, this is a carrier, which the cylinder is attached to. And the carrier moves up and down on this, which is our lift. And of course we have our motors and our gears and the chain that makes it all move and come up. I'm gonna pass it over to Jason.
So one more thing about this cylinder. So in the real world, you could use a cylinder on, like, say, a conveyor belt. You could push like items onto a conveyor belt, which would allow things to move. And also this elevator, if you go to like Sam's Club or something, you could see like those machines that go up and pick something off the top shelf. That is basically an elevator, and it's the same concepts. And through first, you really get to discover things that you use in these robots can be used in the real world.
So as the robot's going forward, it's trying to aim and place its hatch panel onto the carrier there. To aim and then lower the hatch panel onto the field. Lower out, and then it retreat its arm. And now it's on.
Hello, I'm Vincent, and I am the head captain, the build captain of our team, Robotics, team number 5726. This is Enrique. He's the co-captain, and this is Mystique, who is the safety captain. So this is our robot. Its nickname is the Robots. Now, instead of we wanted to focus on cargo also. So in the competition, you're supposed to collect these cargo balls, and the cargo balls shoot out into a kind of like opening. So in this robot, we incorporated motors. We incorporated use of gears with different gear trains, motors, all of it's connected, same as theirs, to a battery in the back. And it also has the rotor, and it has everything else like theirs as far as electrical wise. We did not use pneumatics, but we did use pulleys for an elevator system, and then we used the shooting system for the cargo. And we can demonstrate it too.
So what I have in my hand right now is a cargo ball. So our robot is able to intake the ball and shoot it out, which I will demonstrate now.
We see how these robots operate, and you see the young people that designed them and built them and actually entered them in a competition and went into the finals, which is a very good start. What I'd like to know is, we'll just start at the beginning. What is your major in school? I mean, what do you like, engineering or?
Okay. Right now I'm majoring in biology, and I would like to be an environmental scientist. Try to help back towards the environment.
You're on the right program.
Yes,
this is the Green Connection.
Yes, I'm from STEM, Early College High School in Harno District, so they're trying to get us into science, technology, engineering, and mathematics. So
and how do robotics fit into what you want to do?
Robotics, I guess it expanded my mind, because I not only would be like studies about how to save the environment, but also you have to build things and you have to be in it. So I think with robotics, I was able to do hands-on learning and able to solve problems and and work with different people and collaborate to solve problems.
So it'd be a clean way of operating.
Yes,
yeah.
Yes, ma'am.
And clean up our air, which is going to need more of it.
And the water and the ocean, everything.
We need to work with the climate a little bit, don't we?
Yes, ma'am.
Okay. Thank you. Next one.
Hi, I'm also from STEM Early College High School, and I'm going to be a junior, and I'm going to be majoring in engineering because I hope to be a mechanical engineer.
You want to be mechanical engineers actually design the equipment, the machines?
Mm-hmm.
Or
yes, it involves a lot of like engineering, math, science, things of that sort.
Okay, thank you. And you are contributing to women taking over the world.
Yes, ma'am.
That's really great. What is going to be your major?
I want to major in engineering, and more specifically industrial architect. So
industrial architecture.
It involves with designing and putting effort to make something work.
And so the robotic equipment, which would be used in industry and even in architecture, would be something that you'd want to design, which is really interesting. Are you into designing buildings and all?
Yes. I've made a few sketches before, and it's something that I'm really interested in, and robotics has helped me focus more on what I want to do, and it made me realize that that's what I want to do.
That's fantastic. And eventually, maybe we'll all be replaced by robotics or by women. Okay, thank you so much. And you?
Hi, I'm Andrew. So I want to study computer science when I'm older, and hopefully robotics has actually helped me learn a lot more computer languages, as well as learning real-world applications for programming.
And how you actually program these? Did you work with the programming of these?
I did actually. So within our 6 weeks build time, we figure out what we want to end up the robot doing, and then we have to figure out different solutions for how are we going to program for it to do that. So it's been a wonderful
It's all
experience.
beyond me. I just don't understand. But I wish you a lot of luck.
Alrighty,
What
thank you.
year are you in? When are you?
So I'm a junior and I'm going to senior year now. So
Okay,
thank you.
thank you.
I'm Jason Folsom, and I go to Brooks Academy with these guys, and I want to major in computer science as well. But ironically, on the team, I do more of the mechanical aspects, and I help design the robot, and I did a lot of the wiring on this.
It's amazing how you put all that together. I don't know how your head works that out. Fantastic.
It's a combination of all of our heads.
You're all so smart. Thank you so much. Wish you good luck.
So I'm Sarah, and I want to study law. I want to study criminal justice, and on the team, I'm basically part of the outreach. So I'm the one who goes out and I want to assist the community. Like in the Folklife Festival, when you saw us, we were there assisting people and showing people our robot and things like that. So yes, ma'am, it's an honor to be on the team, and it's a great experience. Yes,
That's what I do, marketing and public
Yes,
relations.
ma'am. Yes, ma'am.
Well, we'll give you a disc and you can take this around and show everybody.
Perfect. Thank you, ma'am.
Thank you so much.
Yes, ma'am.
My name is Matthew Villanueva, and I'd like to study aerospace engineering. And robotics has just taught me how to work with a team and see how that. And first has done a lot with the testing our real world application, and just working together to complete an objective has put that to the test.
And what year are you about to graduate? Or
I'm class of 2020, so I'm a senior this year.
thank you.
Hi, I'm Caleb Zavisky. I just graduated from Brooks Academy, and I want to study mechanical engineering to be my major. My minors, I want to do electrical engineering and something in computer science.
And did you help design these?
Yes, I did most of the mechanical, so like building the elevator and stuff like that, and most electrical.
And what do you think the future, all of you, what do you think the future is going to be for robotics?
A lot of stuff is going to be more like controlled by robots.
More
now.
efficient,
Yeah.
and yet we're not going to get rid of all of the human beings.
Yes, because we're going to need the future coders to code the robots. that are gonna
Just
take
make
jobs.
their work more efficient.
Yes.
Well, thank you so much, all of you, for coming. Thank Brooks Academy for having this program. This is an after-school teamwork. I believe there's 10 on the team, and I've been counting it. I think we've got them all here. And it's really gratifying to know that students spend their after-school time to do this and to create these robots that I don't understand anything about, but it's amazing how that works and how their team works together with the computing, the design, and the engineering. And so thank you so much for doing it, and thanks so much for promoting it, and thanks so much for being here. Jeremy. This is Jeremy Rios. He's the head of the science department at Brooks Academy, and he's worked with these wonderful, wonderful young people on robotics. They're interested in various other things, and they're putting their knowledge all together, and this is a fantastic team. Now, if somebody wants to join your team, they have to go to the academy first.
So they can actually don't have to attend Brooks Academy. I mean, it would greatly be beneficial, but they just need to go in on first.com and then they can.
And so it's an after-school program, and I believe we have your email on the screen. If not, it's jeremy.rios@brooksacademy.org, right?
Yes.
And are you having any summer programs that people can that young people can come and join to get an idea of what you're doing?
Well, as far as for the remainder of this summer, we're kind of tapped out. But during the fall semester, we'll have plenty of opportunities to show off.
If you're interested in learning more about robotics, email Jeremy. Thank you for being with us. I hope you've got some idea of what robotics can do in industry, in your daily life. It's robotics are in the future. Thank you for so much watching, and stay green.